All right, so in Chapter 9, the only thing new that you guys are going to be looking at is the use of multiple regression. So I want to start by letting you know this is going to be based on some concepts that were covered in Math 120, your previous stats course, which is just basic linear regression and correlation. So you can go back to the Math 120 review that I posted for you and look at the information from sections 9.1 and 9.2 if you need to go back and review some of that information. Now, the main thing that I want to show you here is the use of technology to come up with a multiple regression equation, because the mathematics that are associated with determining the slope and the intercept for a multiple regression equation is much more complicated than what it was for a basic linear regression equation, and thus this is not something that you're going to be able to do by hand. All right, so when we talk about a multiple regression equation, the main difference between this and a simple linear regression equation is the number of independent variables. So with basic linear regression, there is one independent x variable, all right, one explanatory variable. In multiple regression, you have more than one variable that are going to be explaining the things that happen to the dependent variable y. All right, so for example, we have a data set here that has 3 independent variables. Okay, we've got our salary, that's our response variable, our y, and then we have 3 things that are going to be explaining the changes in y. We have the number of years of employment, we have the number of years of experience, and we have the number of years of education. So we are trying to determine here the role that these 3 independent variables play in determining what the corresponding salary will be. So you'll notice what we want to do here is we want to come up with a multiple regression equation that will model the data. All right, now we define the basic format for a multiple regression equation here. Now what a multiple regression equation will do is it will allow us to predict values of y, that's why we use a y hat here, it's an estimate, based on the values of the independent variable. Now again, just referring back to the basic format, we're going to start with an intercept. That's like our constant term, and we use b to denote that. And then for each independent variable, however many we have, we need to define the slope, or the rate of change, associated with that variable. So since we have 3 independent variables here, we're going to have a slope associated with x1, the years of employment. We're going to have a slope associated with x2, the years of experience, and a slope associated with x3, the years of education. Now, like I said, for multiple regression, the mathematics are pretty complicated in terms of determining what the slopes and the intercept are going to be here. So we are going to rely on technology to find that. Okay, so at this point, I'm going to go to StatCrunch. So I've opened up my data here in StatCrunch, right? I've got my dependent variable y, my salaries, and then my 3 independent variables, employment, experience, and education. All right, so to get my multiple regression equation, I'm going to go to my stat menu. And under your stat menu, you've spent a lot of time here. Under your stat menu, you're going to see a section labeled regression. All right, so I'm going to go to regression. And because I have more than one x variable, all right, one x variable is simple linear regression. Because I have more than one x variable, I'm going to go to multiple linear regression. Now, there's lots of things you can do here in terms of graphing, in terms of hypothesis test, but all we want to do is come up with the multiple linear regression equation. So all we have to do here is select our y variable, right? That's our dependent variable, that's our salary, and then make sure for the x variable that you select all 3 of your independent variables, right? The employment, the experience, the education. Now, you don't have to worry about anything else on this menu, all right? As long as you put those things in, x and y, you're going to hit compute. and you're going to get a table of information that gives you everything that you need to model the relationship between these things. So you'll notice I've got an intercept, that's that B term, and then I've got estimates for the slope for each of my independent variables, the employment, the experience, the education. All right, so using that information, all right, so I just put a little screenshot for you here. I'm going to come in here and I'm going to use these values right here to define the multiple regression equation for the data set that we have here. All right, so looking back at how I define this relationship, right, we're trying to predict the value of y, the salary, and we're going to do this using the intercept first. That's my B term. All right, so right over here, I'm looking at a B term of 49,764.4. I'm going to round that to 1 decimal place. Now that's my constant term, so it doesn't involve any of the x variables there. And then I'm going to go to my first x variable, which is the number of years of employment. So looking at my output here from StatCrunch, right, looking at the employment, I've got a slope there of 364.4. So that's going to be my M1, 364.4, and that is the coefficient of x1. Now I'm going to do the same thing for each of the other independent variables, the experience and the education. So for experience, I have a slope of 227.6. So 227.6, that's going to be the coefficient of x2. And then lastly, the years of education, 266.9. So 266.9 will be my coefficient of x3. Now, what I have defined right here, this is what we call the multiple regression equation. It defines the relationship between the salary and the 3 independent variables, right, which again, x1 is the years of employment, x2 is the years of experience, and x3 the years of education. All right, now, the first thing that I want to note that I can do anytime I have a regression equation, whether it's simple, linear, or multiple, is I can plug in values of x and use that to predict the value of y. All right, so for example, all right, we want to use the regression equation to predict the salary based on the following conditions. All right, so our first example here says we want to look at 12 years of current employment. All right, now remember employment is x1. 5 years of previous experience, remember experience is our x2, and 16 years of education, where education is our x3. So all I'm going to do is go right back to my regression equation, which will predict the value of y hat. I'm going to keep my intercept, 49,764.4. And then I'm going to plug in each value of x. So remember the employment, all right, the slope, the rate of change was 364.4. And then I'm going to plug in for x1, 12 years of employment. And then my experience, 227.6. And I'm going to plug in the years of experience at 5. And then my education, 266.9 was the slope, and I'm going to plug in my 16 years of education. And so if I evaluate this, again, what I'm estimating is the salary, a value of y hat If I evaluate my equation here, I'm going to estimate the salary at approximately $59,546. That's for 12 years of employment, 5 years of experience, and 16 years of education. And I can do this for other values of X as well. In fact, if you want to do that for the second example here, all right, I'll give you the solution here so that you can go in and check it. For 4 years of employment, 2 years of experience, and 12 years of education, if you evaluate the same regression equation, you should approximate the salary there at $54,880. So that's the use of a regression equation, is to plug in values of X and predict the corresponding value of Y, because what the regression equation does is it models the relationship between X and Y. All right, now, you do want to make sure, in addition to using the equation and making these predictions, that you can interpret some of the basic values that are associated with the regression equation. Now, one thing to note is just correctly interpreting the values that we use to define our multiple regression equation. For example, here, if we look at the slopes, the M1, the M2, the M3, what those values tell us is how the value of Y would change if the other values were held constant and that particular variable was increased by 1. Okay, so just for example, if I were interpreting the slope here on X1, all right, what that 364 tells me is I can expect the salary to increase by about $364 if everything else stays the same, the experience, the education, but the number of years of employment increases by 1. All right, and the others are going to be the same. If everything else stays constant, but the years of experience increases by about 227.6, then let me rephrase that. If the number of years of experience increases by 1 year, then I can expect the salary to increase by about $227.62. All right, now the other values that you're going to be asked to interpret here are the values that you're seeing right down here at the bottom. Specifically, the coefficient of determination, that's the R squared, and the standard error of estimate, which is what's labeled here as the root MSE, the root mean square error is what that stands for. Now, the way I interpret those, the coefficient of determination tells me the percentage of the variation in Y that can be explained by the multiple regression model. So if we look at our R squared here, what we're saying is that approximately 94.38% of the variation is explained by our multiple regression equation or a multiple regression model. Now, that's a percentage that we want to be high, because the remaining percentage here, about a little over 5%, would just be random error. And so the higher that random error is going to occur here, the worse that our regression equation is doing in terms of making that prediction. So that is a percentage that we want to be high. Otherwise, our model, our equation is not going to do a real good job of making accurate predictions. Now, the standard error of estimate gives me an idea of the difference between the actual salaries and the salaries that are predicted by our regression equation. So this is something I don't want to be very large. I don't want there to be a lot of discrepancy between the two. Now, what our root MSE here are $659.49. That's telling me that overall we have a difference of about $659 between the actual salaries and the salaries that are predicted. by our regression equation. So that's pretty good. You know, we're talking about just a little over $650 difference between what those salaries actually are and how the regression equation will predict them. If that was a big number, if we had thousands of dollars difference between the two, then we would say, okay, this regression equation is probably not that good in terms of making accurate predictions. All right, so again, I want to remind you, if you need to go back and review the basics of correlation and regression, simple linear regression, please go back and look at sections 9.1 and 9.2 in the Math 120 review. What you'll be doing in 9.4, and this will be added on to your cumulative final exam, we'll be looking at multiple regression equations with more than one independent variable, writing the equation, using it to make predictions, and then making sure that you can interpret values like the slope, the coefficient of determination, and the standard error of estimate.